Hi there. Now in this video what I want to do is demonstrate to you how you can use Taylor's series to find a solution to a differential equation. And in this example we're given that d2y by dx squared plus y times dy dx equals x. And at x equals 1, y equals 0 and dy by dx equals 2. So we've got to use a Taylor's series to find a solution to the differential equation in ascending powers of x minus 1 up to and including the term in x minus 1 cubed. Now to do this we need to use the Taylor's series that involves expansions in ascending powers of x minus a. And that formula, just as a reminder, is this one here. Now, when we compare this formula to expanding in terms of x minus 1, a would have to be 1. So when a is 1, we get this version here. So if I was to let y equal f of x, then providing we can work out all these values, we'll be able to get a solution to our differential equation. So that's essentially where we start with this. Just say let y equal f of x. Now we're going to need to get these values here, f of 1, f dash of 1, the first differential of f of x when x equals 1, and so on. And already I can see that we've got several of these values, because we know that when x equals 1, up here we're told that y equals 0, and also dy by dx equals 2. So what this means is that therefore when x is 1, y is 0, that means that therefore f of 1 must equal 0. And also we know that dy by dx equals 2 when x is 1, so that means that, we'll just put and, the first differential of f of x when x equals 1 gives us 2. So we've got our first value here and our second value here. What we need to get is the value of the second differential of f of x when x equals 1. And we can easily do this from this statement here, which I'll call 1. So we can see that also from 1, if we substitute these values in, what do we get? Well, we've got d2y by dx squared, so d2y by dx squared, plus y times dy dx, so that's plus y. Y was 0, times dy by dx, which we've seen when x is 1, is 2. So it's going to be 0 times 2. And this equals x, and x was 1. Well, clearly this term is 0, so what we've got is that d2y by dx squared must equal 1. And from this, it follows that f double dash when x is 1 is in fact 1. So we can use this to substitute into here. What we don't have though is the value of the third differential of f of x when x is 1. And to do this, we need to go back to here. And this is often the case in these kind of questions. We need to differentiate this now with respect to x. So what I'll put in here is differentiate equation 1 with respect to x. Okay? Now if we differentiate this with respect to x, we take the first term, differentiating d2y by dx squared with respect to x is therefore going to give us d cubed y by dx cubed. Now when it comes to differentiating this term with respect to x, we've got a product of two variables here. So we're going to need to use the product rule for differentiation. So if we take one part of this as y and the other part as dy dx, then by the product rule, we'll take the y part and we'll now multiply it by the differential of dy by dx with respect to x. So that's going to be d2y by dx squared. And then plus, we've got to do it the other way around. We take this part, dy dx, and we multiply this by the differential of y with respect to x, which is going to be another dy by dx. So really what we've got is dy by dx all squared. I'll write it like this though, just for the moment. And now we've got to differentiate x with respect to x, and that's going to be just simply 1. So now we've got this, all we need to do is just substitute our values in. And we know that when x equals 1, y equals 0, and dy dx equals 2. And we've also found out from up here that d squared y by dx squared, well, that equaled 1. So if we take our values here and substitute them into this equation, let's just write that in, that sub into, what does that give us? Well, we've got d cubed y by dx cubed, d cubed y by dx cubed, that's the value we're trying to find, plus y times d2y by dx squared, so that's going to be 0 times 1. Well, that's going to be 0. I'll just put that in though as 0 times 1 for the time being. And then plus dy by dx all squared. dy dx was 2, so we've got plus 2 squared. And this equals 1. So from this, we can see that d cubed y by dx cubed, well, we've got plus 4 here equals 1. If I take 4 from both sides, then I've got 1 minus 4, which is going to be minus 3. And it follows from this that when x equals 1, the third differential of f of x comes to minus 3. Now with these results that we've accumulated now, we can work out our solution for y in ascending powers of x minus 1 by using the Taylor's series. So I'll just say from the Taylor's series, okay, what do we actually have now? Well, instead of f of x, we've got y, so therefore we have y equals, and it's going to be f of 1. Well, f of 1 was 0. So that term vanishes. Now we have f dash of 1. Well, that was 2. So it's going to be 2 times x minus 1. 2 times x minus 1 then. And to this we add now f double dash of 1 over 2 factorial times x minus 1 squared. Well, f double dash of 1 was 1. So we've got 1 over 2 factorial there. 1 divided by 2 factorial multiplied by x minus 1 all squared. And for the last term here, f treble dash of 1 over 3 factorial, well, f treble dash of 1 we found out to be minus 3, so that's minus 3 now, divided by 3 factorial multiplied by x minus 1 all cubed. And we've got other terms and so on. So when this is simplified, we therefore have y equals 2 times x minus 1. We don't need to expand the brackets. Remember, we're doing it in ascending powers of x minus 1. 1 over 2 factorial, well, that's a half, so that's going to be 1 half multiplied by x minus 1 all squared. And here, 3 divided by 3 factorial, 3 divided by 6 in other words, is going to give us 1 half again. So it's going to be minus a half of x minus 1 all cubed, plus and so on. Now do remember that this is only an approximate solution to our differential equation, and it's only going to be valid for values of x which are close to the value of a that we took. In this case, a was 1 at around the point where x equals 1. So it's not going to give you solutions for any value of x. Anyway, well, I hope that's given you some idea of how we go about solving then differential equations by this particular method.